Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 2870, minimum number of operations to make array empty. This is a medium difficulty Leetcode problem, and we're told that we're given a zero-indexed array called nums consisting of positive integers. And there are two types of operations that we can apply on this array, where the first thing we can do is choose two elements with equal values and delete them, or choose three elements and delete them. And we want to return the minimum number of operations required to make the array empty, or -1 if it's not possible. So when would it not be possible? Well, it would not be possible if there's a number with 1. Every other number can either be, or any other natural number can basically be divide, removed, we can remove a 3 and then a 2, in that sequence. So for example, if we had a 5, we can remove 3, we had a number x which has a count of 5, we can remove it 3 times and then we can remove it 2 times, or 2 times and 3 times. But if we had 1, we couldn't remove it 3 times, or 2 times. We could not do that, so we would end up returning -1 because it would not be possible. And yeah, so how would we solve this kind of problem? Well, we're looking at an example over here, and it shows that we apply the first operation at certain indices, and we basically cancel these numbers out. So we see 2 and we see 2, and then we see a 3 and then a 3 and then a 4 and a 4. So we can cancel these numbers out, but occasionally you'll get a single number where it's not possible. So we have 1 here, for example, which only appears once, so it's impossible to empty the array. So how can we actually solve this problem? Well, the first thing that I kind of thought was, we can use XOR. We can use XOR because 2, 3, 3, and 2. You XOR all of these. These should be XORs. Will just end up 0. So I looked at this and I was like, okay, maybe there's something to do with XOR over here. But then I realized that, once we, this could be at any side. So we can have 4 and then 4. The XOR does not equal 0, and they don't cancel out because the subarray between these two indices does not, they don't all equal the same, so they won't XOR to 0. So the commutative property here won't work. So instead, this problem, with a bit of trial and error, I figured out is a greedy problem. It's a greedy frequency counting problem. And the way we're going to start is we're going to have each number x, and then we're going to have the count of that number. So let's say we have 5 and 4. 5 appears 3 times, 4 appears 2 times. As we go through each number, each value, we'll say, we can remove 3, we can remove 2, and then we'll eventually realize that we can return a list. But we want to do a greedy problem. We don't want to just say, can we remove it or can we not? We want to say, let's first check if it's removable by 3. So, in this example, 6, we can remove it -3, -3, so that's only 2 operations. Or we can remove it, -2, -2, -2, but that's 3 operations. We don't want to do 3 operations. We only want to do the minimum number of operations, which is going to be 2 operations. So we want to first check if it's divisible by 3. So if x is divisible by 3, or actually let's say k is divisible by 3, if there's a remainder, then we need to check, we'll just increase our count by 1, because, let's say we have 4 divided, or 4 mod 3, we would get 1, and we would say let's add 1 plus 1 to our result, so the number of operations it would take. Because think about it, 4 can, instead of doing -3 and then getting confused over here, we can say we can split it into -2, -2, and then this will end up cancelling it out, so we can do 2 -2 operations as opposed to using a -3 operation. So I hope that logic kind of made sense. Let's actually solve this problem. First thing we want to do is create a hash map, which is going to solve the initial counts, and we can say for each number in nums counts, counts num equals, we can say counts dot get number, or 0 if it doesn't already exist, and increment that by 1. So now we've created our hash map, which basically has each number and a count. What do we want to do next? Well, we want to say for each number in count.values. We're not worried about the numbers themselves, we're just worried about how many times they appear. If that number is equal to, actually let's just set this to C, it's just a bit simpler. Otherwise we're going to think it's the number that corresponds to the count. So we're going to say if C is equal to 1, return -1. It's not possible to do remove 2 or 3 elements from an element which only appears once. Otherwise we want to say operations, and now let's create an operations variable. Operations is equal to 0 initially. Operations, we're going to increment it by C divided by 3. Now, if this is just 3, happy days, just going to be 1, fantastic. But if this is 3, if this is 4 mod 3, well, then we're going to get the 1, like we discussed in the previous example. So what we want to say is if if C mod 3 it does not equal to 0, well, then we want to increment our operations by 1, and that will basically allow us to use -2 instead. So it will count that as an operation, and then we just want to return operations. Let's hope I haven't made any syntax errors, and I have counts.values, not count.values. Okay, and we passed all 748 test cases. So I hope the explanation made a bit of sense. It is a bit confusing, and there are a couple of ways which you'd think, prefix sum, no, not sliding window, but prefix sum or XOR, something like that. But it's basically just a greedy problem. I think there's also dynamic where you can solve this as well. But this is just a greedy problem. Time is going to be big O of n, and so is space. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.